Yeah. At the end of the day, production work is definitely where the money comes from. If you can turn up to work, load a whole bunch of billet into your machines, press go, and then go to the pub,
The dream.
that's amazing.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Dan Melling from Kiwi CNC. Now, New Zealand's a small country. We've only got about 4.5 million people, so understandably, it's not that often we get to interview someone from our home country. Dan has been running Kiwi CNC for a number of years now, and he is producing parts at the absolute top level of anything you've seen anywhere in the world, which is a credit to him and his small business. We talked to Dan about how he transitioned his career target from originally wanting to be an Air Force fighter pilot through to learning the basics of machining in the Air Force, then coming out the other side and founding his own business, Kiwi CNC, how he's then built that up and the sort of jobs he's taking on. We also learn about his transition from manual machining through to learning the skills of operating CNC machinery, and of course then goes hand in hand with learning 3D modeling and CAD software. Before we get into our episode with Dan, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune, how to build engines, how to construct wiring harnesses. We also cover fabrication, 3D modeling and CAD, car setup, race driver education, and data analysis, just to name a few of our topics. All of those topics are taught using online high-definition video-based training courses that you can take from anywhere in the world, provided you've got an internet connection. If you do want to learn more about our courses and how they work, you can check them all out at hpacademy.com/courses. Also, there is no risk purchasing a course from us. If you buy it and decide it's not quite right for you, or you just didn't like it, let us know. We give a full 60-day, no questions asked, money-back guarantee. And as a podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. I'll put a link to that and the courses in the description. All right, let's get into our interview now. All right, welcome to the podcast. Dan, thanks for joining us today. And like usual, let's get a bit of an understanding of your background. How did you get into cars initially?
Okay, well, it took a little while. I wasn't into cars originally. I was at school. I was into planes. I actually got my private pilot license when I was in 7th form, while I still had my restricted and all my mates were rolling around doing burnouts and skylines.
You really just jumped the queue there.
Yeah. Well, I could take them for a fly, but I needed one of them to give us a lift out with all my mates to the airfield.
Interesting.
Seeing as I couldn't take passengers in a car at that point, so so that was interesting. But that led on to wanting to join the Air Force.
On that note, before we get into the Air Force thing, this actually kind of mirrors my background. I started learning to fly when I was at school, and my intention back then was I wanted to be a commercial pilot. And I think I did about 50 hours back then by the time I was maybe 17 or 18. And then obviously life went in a different direction. I only kind of finished that off in the last few years, but was that the sort of intention that you had, or was it just for fun? Okay.
Yeah, that was it. Yeah, I love planes. Yeah, that was going to be the thing before I got dragged off into eventually what I do now. And I haven't actually been flying, or I haven't flown since before I joined the Air Force. Yeah, that would have been 2005. Failed to get in as a pilot.
So the Maverick Top Gun dream was crushed?
Nah, I don't even look like Tom Cruise, so that's all good. So I was given a couple of other options of joining up into the Air Force, and I chose avionics, which is all the electrical gubbins inside the aircraft. And right before I started my trade training, I went through a general engineering phase, and part of that is machining. I did all right at that, and the instructor convinced me to change to being a machinist. And I did, at the time, until I'd seen the machines, I hadn't even known what a machinist is or does or anything. So I really enjoyed it. And yeah, had a couple of beers at the bar on base and changed over the week before my course was supposed to start as avionics.
So you never actually went down the avionics path straight into machining?
No, straight into machining.
Now, is this, obviously, we're in New Zealand, so things, I guess, are different in different parts of the world, but as I understand it, armed forces pretty much, it's not just fighting on the front line or flying fighter jets. There's a lot more to it, and obviously you're machining, and you get to learn those skills essentially and get paid at the same time. Is this a pretty viable way of picking up a trade?
Yeah, it's actually a really good way of doing it. It's like an apprenticeship. You have to obviously do a few extra things as part of the military, but effectively, you go in, you do all your recruit course and learn how to use guns and put on gas masks and all that sort of stuff. And then you do your trade training, which is say 9 months long or something like that, and then you'll do a on-job training, which is kind of like your apprenticeship for a couple of years, and then you'll be back into your senior course, which is honing skills and doing a little bit more specialized stuff, a little bit more accurate stuff, and then you're out for another return of service, which is basically proving what you've been up to and starting to get into it. So I think it's a great way of learning.
Yeah. Out of interest, so once you've gone through the trade and you're a machinist, what sort of parts are you actually making in the Air Force? Is this sort of replacement service parts for aircraft, or is it a lot broader than that?
Yeah, we did the occasional replacement part for aircraft. Generally, the main idea was on maintenance, so helping out with servicing on the aircraft. Sometimes you'd be making up jigs and fixtures to drill out a bolt that someone had snapped inside an engine. That was great fun. Or remounting parts on the aircraft. You'd be doing also tooling for guys to work on the aircraft, but also the ground equipment. We did a lot of ground equipment work as well for, they had their own diesel mechanic workshop. We did a lot of stuff for those guys, and camp parts. So we were involved with some of the pack-up stuff for that, and water filtration and things like that. So quite a variety, yeah.
I'm guessing back then you're working on manual machining equipment, and we're going to talk as we go through this about manual equipment versus CNC and go a little bit deeper into what the different equipment is and what it does. But yeah, for the moment, is that a safe assumption?
Yeah. So we had a good variety of manual machines. We went all the way from, simple turning and milling, and there was a little bit of spark eroding and cylindrical grinding and surface grinding, bit of heat treatment. That was really good.
So you got exposed to a broad range of different elements within the machining as a skill set.
Yeah. And our Air Force, not being a huge Air Force when you consider it, for the rest of the world, you could say it was a little bit traditional, dated even a little bit, but that served me quite well in terms of learning a broader range of parts and not just going into the cream stuff straight away, you could say.
Yeah, okay. You mentioned that you didn't really start with a passion for cars, but you've turned your machining skill set and knowledge definitely into the automotive industry. So at what point did that sort of crossover occur and you got deep into the car scene?
Well, fairly early on in the Air Force, I pretty much lost interest in planes, which tends to happen sometimes when you do that. So the next thing would be cars, and I did my first engine transplant in the car park outside barracks in winter in Blenheim, which was very cold, running, extension cords with neon lights and stuff on the end so I could see what I was doing. And sort of just went headfirst into that stuff, which was great. Started catching up on all my mates who had been into cars for years. And it's kind of grown from there.
I'm guessing at this point you've got a fairly broad skill set in terms of general mechanical skills as well as the machining side of things, which lent itself well to what you're doing with cars.
Yeah, I'd like to think I sort of brought to the party a little bit of a natural ability to figure out how things work. And so, I guess at the end of the day, pulling apart a car and putting it back together is kind of like a fancy Lego set. And there's obviously, some fancy parts of that. But sort of just bumbled my way through it.
All right, so take us through sort of post-Air Force. How long were you in the Air Force, and at the point you got out, what was next for you?
So I was in the Air Force pretty much until the day I could leave after my return of service. I'd sort of got to the end of what I felt I could do there, and I was interested in getting out, seeing the world, working in a place that, a commercial environment. And I had a bunch of people around me leave, go to Australia. That was one of the options, which I eventually took up. But I was also offered a job instead down in Blenheim at a vintage aircraft engine workshop. So my boss, Tony, took me on at Classic Aero Machining Service, and we did all sorts of stuff with vintage aircraft, which translated quite well from the Air Force.
For those listening from outside of New Zealand, safe to say if we ever get invaded, I'm not going to be holding out too much hope that the New Zealand Air Force is going to be able to defend us.
No, we're not operating any F-22s or anything like that.
No.
We're good at search and rescue.
Yeah.
That's our thing. So we had a couple of interesting projects at Classic Aero Machining where we were making rotary aircraft engines, which isn't...
That sounds scary in terms of reliability, let's be honest.
Well, it's even worse than what you thought. If you look at a rotary engine, which is very different from a Wankel rotary engine in a car, they look a lot like a radial engine, but instead of the engine being joined to the aircraft and the propeller being joined to the crankshaft is joined to the aircraft, and the cylinders are joined and crankcase are joined to the propeller, and they spin around up to sort of 1200 revs. That seems like an exceptionally bad idea. Yeah, they don't really make them today.
That says probably everything we need to know.
Yeah, they're a World War One aircraft engine, and they're pretty impressive. That was great fun.
Interesting. All right, so post that position, what was next? Are we sort of getting towards the point where you're thinking you might start doing something for yourself, or is that still a little way down the line?
That was a little wee way off. Myself and my wife decided to do a bit of an overseas excursion. So I did a stint in Australia for a year and a half, CNC machining on oil and gas parts out in the middle of absolute nowhere.
Is this sort of getting towards your first exposure to that transition to CNC?
The transition to CNC was actually during my time at Classic Aero Machining Service. Yeah, I was kind of thrown in the deep end there and came out all right. I'm loving it. It's amazing what you can do with those kind of machines. And then, the overseas stuff was actually really different. So I was turning overseas, so CNC turning. Did a little bit of a stint in the UK, making parts for Airbus, and then came back home and went back to the same job in Blenheim. And then that was pretty much when we decided to move out and I started my own setup.
Okay. Before we get into Kiwi CNC and talk about that, let's just sort of dive a little deeper into some of the basics of CNC machining, or for that matter, machining in general. We've had a few guests on the podcast talking about this already, but I think we've probably glossed over some of the terminology and made some bold assumptions that all of our listeners kind of inherently understand that, which may or may not be the case. So I think we dive back into some of these basics. So for a start, what does the term CNC stand for, and how does this technology differ from manual machining?
So CNC stands for computer numerically controlled, which is basically having a computer operate the machine rather than your hands. It does all the same stuff as a manual machine, as a manual lathe or a manual mill, but because it's computer controlled, you can do it a lot faster. You can drive it around curves. Basically, that's the long and the short of it, is that you're not limited by what you can do just offhand, hands flying around on the machine.
I can understand the benefit in terms of speed, probably also in terms of accuracy and repeatability. Is it also safe to assume that CNC machining centers can perform more complex tasks that even a competent or very, very highly skilled manual machinist would struggle to do?
Yes.
Okay.
Yeah.
All right. So basically just adding modern technology and computer control to existing technology in terms of mills and lathes, which brings me to the next point. You've already mentioned the term turning. There's lathes and mills. Could you give us a quick high-level view of what those two pieces of equipment are and how they differ, maybe what you would use one for and the other?
So there's one really main difference between a lathe and a mill in the fact that a lathe, you attach the workpiece to the chuck and the workpiece spins, and then your tool is stationary, moves along around the axes and machines the material off around the outside of the part, basically. Whereas a milling machine is the opposite way around. So your workpiece is bolted down to the table, and then the tool spins and drives its way around the part. So a lot of the time you'll find that parts are used, they're done in a lathe and then finished in a mill, or in a mill finished in a lathe, and they work simultaneously really well together.
Really, it just depends the shape of the part that you're making as to what machining operation would be required to produce that.
Yeah. So say you're making a wheel, You would turn up the shape first on the lathe, and then you could mill the spokes out afterwards, for instance.
That makes sense. The other thing we hear about when people refer to CNC machining is the number of axes that are available. So you hear sort of 3, 4, 5 axes. So can you give us a high-level understanding or a quick understanding of what those terms mean?
Yeah, so an axis refers to each direction that the machine can move its parts in. So if you think of the table in front of you, a 3-axis mill, which is basically your start out for a mill, you don't get less than that. Your x-axis will be the table moving left and right. The y-axis, the table moves in and out, and then the z-axis is the head up and down, it's vertical. Then you're just adding stuff from there. So you'll have 4th axis will be usually a rotary table on top of the bed, which is used to rotate the workpiece over or spin it or...
Right, so giving the tool access to other areas of the workpiece.
Yeah. It's used for either complex parts, or sometimes it's just used for better productivity. You can do, more operations if you don't have to pull it off the machine earlier.
And safe to assume that the more axes you've got, the more expensive the equipment becomes?
Yeah, tends to be that way. The more axes, the more rigidity that needs to go into the machine, the more processing power.
All right, so another element, the machine itself is only part of the puzzle here. You also have the tool that actually does the machining operation or the cutting on the part. And as I understand it, I'm definitely not a machinist, so bear with me here, but there are a massive variety of different tools that can achieve different outcomes. Obviously, these tools would start to add up in terms of cost as well. So, typically, how many tools would you use on the regular?
Yeah, you're correct. There's a hell of a lot of tools. With your machine itself, the number of tools that you can add into the machine, say for a 3-axis milling machine, they're usually somewhere between 20 and 40 tools will go into the machine. It'll automatically change in between them, and it really depends on the job as to how many tools you might need. So you might have a job that's got a whole heap of sides that you need to machine, and then you'll need to drill a tapping size hole in the part and then tap it. So you've got all your milling cutters, you drill, you tap, center drill, chamfer tool. I find I've got a few regular jobs that will use all of the tools in my machines, which they're 24 tools they hold plus a spindle. I wouldn't mind having another few sometimes, would be good.
Always want more, right?
Yeah, 100%. So, yeah.
And with these tools, short of having a big mishap and actually crashing the tool into something and breaking it in that manner, what's the sort of life expectancy? If you're machining an aluminium material, which is relatively soft compared to steels, and you've got lubricant as well, what's the sort of life expectancy?
Yeah, definitely depends on the material you're doing. It depends on the operation you're doing as well. So whether you're roughing, finishing, doing any deep hole drilling or whatever you're doing. But generally you find, like, if you're kind to your tools, aluminium, they basically last forever. You'll find that they lose their edge and you won't get the same surface finish. But yeah, for roughing tools.
That term roughing, I'm assuming there you're talking about removing larger amounts of material quickly and not quite so worried about what that surface finish is going to look like, and then you go through removing smaller amounts of material and getting the surface finish how you want?
Yeah. So roughing, you're basically trying to get rid of as much material as you can, as fast as you can, so you can get, A, time is money, and B, you can get into the fun stuff of making it look pretty at the end of the day with your finishing tools.
Yeah, for sure. That's the element here, is that unfortunately CNC machining is pretty wasteful because you're trying to take a big piece of solid billet and then carve out the material inside that you want for the finished product. So a lot of waste, correct?
Yeah, huge amount of waste. And I generally find the cooler the part, the more wastage there is. So a few of my parts will end up with up to 95% of the aluminium ends up in the big bin outside.
Fortunately, though, aluminium is recyclable. Obviously, you're getting cents on the dollar for that scrap material, but it does ultimately do another turn. So it's not entirely a waste, is it?
No, it doesn't go into landfill. It goes back, gets melted down, and maybe turned into car parts again at some stage.
In terms of the machining process, I can assume here, particularly if you're removing a large amount of material with this roughing out process, that's going to generate quite a lot of heat in the material. Aluminium specifically, or particularly, has quite a large or high thermal expansion coefficient, meaning that as it gets hot, it expands and changes dimensionally. I'm just interested, what, if any, do you sort of have to take into account with that, the heat and the expansion of the part, versus what that's going to do to the dimensional accuracy of the finished product when it cools back down when it's finished?
Yeah, so, well, the really good thing about the CNC machine is that it's fully enclosed and it's got a huge big tank of coolant underneath it. And you're basically, with aluminium or with anything where you want to use coolant, you're basically trying to force as much coolant as you can into the cutting area.
So it's not actually specifically about lubricating the cutter, it's also about cooling the material.
Yeah, it's partially lubricating the cutter. A lot of it is ejecting the chips away from the cutter. And it's also about cooling the material. So I'll find on some of my parts, I'll be refilling the water and the soluble oil quite rapidly during the day because it'll be evaporating off with the heat that it's pulling out of the part, out of the chips.
Yeah, that makes sense. I assumed it was more a lubricating element than the cooling, so that's interesting. On that same element, you mentioned that the tools don't wear really too much with aluminium, but I mean, I'm assuming there is some level of wear that's going to also affect, again, the dimensional accuracy of your finished part, the precision of that part. Is this something that you need to account for manually, or is this done, using some algorithm within the machine itself?
It will depend on your machine. So with mine, it is manual. You'll be checking each part that comes off, or checking depending on how accurate the part needs to be, will depend on when you check it, depending on how interesting your tool path is or how long the tool is or anything like that. You'll be checking it potentially a little bit more often. And there are offset parameters that you can put on the tool to account for wear. You might end up with, a couple of hundredths of a millimeter that you need to take off a tool so that it will effectively drive the tool closer to the part to take off the same amount of material if it's worn.
Yeah. And I assume here as well, it's sort of going to come down to the requirements of the part you're producing. Obviously, a lot of parts, the dimensional accuracy is going to be very tight. The requirement will be very tight, but others maybe not quite so much, so less of an issue.
Yeah, that's correct. So you might find a part that's mostly just finished to look nice around, the majority of it, and it'll have a couple of bearing diameters in there. So you'll use a different tool to cut that finished diameter, and one that's not going to be affected by doing all the finishing on a different part of it.
All right, now that we've got kind of that bit of a background-based knowledge of machining and CNC machining specifically, let's jump into founding Kiwi CNC. So take us through that. Specifically, I'm guessing you went from full-time employment, and I'm always interested to talk to entrepreneurs who have jumped into this industry and find out how they overcome that fear of going from the regular pay packet that they could rely on to sort of that leap of faith.
Yeah. It's very scary. I managed to wangle my way into it through selling a house. I had a house in Blenheim where I was working at the time. Myself and my wife had enough saved up to afford a house without having to rely on that income. And bearing in mind at the time, houses weren't average $1 million like they seem to be now. So I ended up with a small amount of money that I could invest into the business at the same time. I moved away from Blenheim and took up a job working for Fonterra as a maintenance fitter, maintaining bottling machines and packing machines. That was on a 4-on, 4-off shift cycle, and that allowed me to buy the gear, set it up in the workshop, start making parts, and then I did that I was operating for maybe a year and a half, and I ended up doing, instead of 4 days on, 4 days off, I'd just do 4 days on in one job and 4 days on in my new job, and didn't have enough time in the day to keep up with demand, so I had to leave, and that was it.
Right, so you kind of got almost like a soft start. You've got that 4-day on deal with Fonterra, so you've got some guaranteed income, and it let you sort of test the water with the Kiwi CNC business idea.
Yeah, that's correct. Yeah, I didn't have to pay myself a wage, didn't have to worry about paying myself a wage for the first little portion of starting it up, and that took the pressure off. It sort of turned out that I could have just gone straight in. There's enough work out there that, I was sort of busy from day one.
It's always that fear of the unknown, though. So I think the way you approached it makes a lot of sense. I'm guessing that you didn't also just run out and drop a couple of $1 million on some brand new CNC machining equipment at the outset. How did that work out? What was sort of the minimum viable equipment that you required to actually start the business?
Yeah, that's correct. So CNC gear is everybody knows it's not cheap, and they're right. So when I started, I was lucky enough that I was talking to my boss at the time, and he knew what I was up to. He sort of asked, what sort of machinery did I want, and I pointed at one of his mills and said, I want one of those. And so he used that as an excuse to upgrade. So I got a pretty good deal on that machine, not cheap as chips, but that was great. And the good thing with that is that I'd done a hell of a lot of work on that machine. I knew how it had been treated, how it had been maintained, and that's the really scary part about buying secondhand CNC gear, is that it's very finicky.
You could be buying someone else's problems.
You can be buying an absolute lemon, and I was lucky at that time. So I took the CNC mill, which was just a 3-axis at the time. I've since added a 4th axis to it, and it's just a Hartford meter bed, pretty standard thing. Doesn't really go fast enough for me now.
Needs have grown.
Yeah, that's right. Yeah, but that was perfect for setting myself up.
Okay. And what's it look like today in terms of the equipment you've got?
So I've added, there was another one that popped up, pretty much an identical machine was being sold off out of a manufacturer here in New Zealand. It had been thrashed to death, but the machinery seller was trying to get rid of it, and he put a new spindle in it for me, and it's, it paid itself off in the first couple of jobs that I did on it, and that's been really good to have 2 machines, even though they're nothing flash. Since then, I've got a little manual mill. You always need one of those in your workshop, and a manual lathe. Just shouted myself a new one of those, which is, can't wait to try it out.
I guess, again, just coming from outside of the industry, I wouldn't have assumed there would still be a need for the manual equipment if you've got CNC. So just talk us through that. What are you doing on the manual lathe and mill?
Yeah, really good question. A lot of people will assume that you've got a CNC machine. Why would you go back to manual machining? You always need the manual gear to support the tricky little jobs that you can't do in the CNC. So there's things like you're limited to the size of the travel that you have in the CNC and the amount of area you've got inside the enclosure. So with things like a manual milling machine, you can do crazy stuff like, bolting things on the side of the mill, not even on the bed, and you can tip the head over and do, like I did a set of trailing arms for a Class 1 off-road truck, and they had integral brake lines in them, and that was something that there was no way I was going to be able to stand up a 1.5 meter long trailing arm inside a CNC machine. So that was a good fun time to chuck it on the manual mill and drill those holes. So yeah, you do always need the manual machines for things like making small fixtures or small parts that you're not going to spend a couple of hours of setting it up in the CNC.
I guess as well, my assumption here would be if you've got a production run that's going on the CNC, you want to keep that thing running because, as you mentioned before, time is money. You can charge that out, whereas it frees up the manual equipment for the smaller jobs, like you're saying.
Yeah, that's true. Yeah, there's all sorts of jobs that you can do on the manual machines that you don't need the CNC gear for in the first place. So yeah, it's just, it's super handy having them there.
All right. At this point, how long has Kiwi CNC been up and running? How long have you been in business for?
I've been running for about 5 years, and of those 5 years, I've been full-time for 3 years.
Okay. Where are you getting your business from? What are you doing in terms of marketing? How have you kept yourself so busy?
Well, it's basically been word of mouth to start. I have an Instagram page, Facebook page, which I don't really tend to as much these days, but I've had a hell of a lot of jobs come through just through Instagram.
Well, that's how we found you, so it's working.
There you go.
Yeah.
There you go. It's a handy tool. And a lot of the work that I've had is overseas. So I'd say the majority of my work at the moment is for Australia, but I've made parts for guys in Europe, America, Japan, all over the show.
That's a good segue into the next question I wanted to ask, which is New Zealand is a small country. We've got 4.5 million people there or thereabouts, and we're relatively remote and freight is expensive. Does that put you at a disadvantage when you're competing with the Plasma Mans and Hypertunes and Platinum Racing products of the world?
Yeah, it does. Yeah, it definitely does, being New Zealand is really at the butthole end of the world, you could say. So it is hard to get stuff down here. I think hourly rates tend to be fairly competitive overseas. That's from what I've picked up. A lot of my work tends to be from guys who just want something for their own car, or something a little bit different, or they've gone to somewhere else and haven't been able to get exactly what they want. The other thing with being a small business like myself, very small business, is that you can afford to do small jobs. You're not bound to doing large jobs for people, and you'll find that a smaller place will be a little bit more interested in doing one-off parts or small runs.
I get that. I also assume that the real profit or margin comes with high volume production runs of a component. So if you could find, a handful of components that you're making, I don't know, 20 or 100 of those in a week, that's going to pay a lot better than taking in the odd one-off job from a customer and then kind of, I'm guessing, finding out that it's actually been designed poorly and you've got to go through and do a whole lot of work before you can even machine it. Is that how that works out, or am I off the mark there?
Yeah. At the end of the day, production work is definitely where the money comes from. If you can turn up to work, load a whole bunch of billet into your machines, press go, and then go to the pub,
the dream.
That's amazing.
And on that note, though, as well, I don't know specifically about the equipment. We had the opportunity to tour, I think it was Turbo Smart many years ago, and all their equipment is set up with automatic loaders. So within reason, they can basically press go to the pub. I'm guessing they're not going to the pub, but
they
whatever.
Might not be.
And that machine will run 24/7 and produce parts. Is that something that you can do or aspire to being able to do?
Yeah. I've recently seen a few places. I think there's Franklin Engineering in Napier. They've got themselves a robot, and that looks like that operates really, really well, especially for what those guys are doing in terms of small parts. If you're doing operations on 20 parts at a time and each part only takes a couple of minutes to machine, then, man, having a robot is great.
I guess it also comes down to these machines, even though you've managed to obviously pick up a couple of deals by the sounds of it, but they are expensive, particularly if you're looking at buying new. And the only way to really recoup that investment is to keep the thing operating. So anything you can do to get more hours of machining on the equipment is going to pay dividends, right?
Yeah, that's right. Yeah, if you can land a job where it's going to pay for a robot, that's amazing. That'd be great. I don't tend to do the small parts that much, and I'm not really too sure why. It just seems to have been how it's worked out, I think. And so far I haven't really felt like I've been cut off at the knees, not having a loader or even someone there to load the machine for me.
What do you sort of see as the next 5 years in this journey, the way you're intending? What's Kiwi CNC look like?
Tricky question. I'm not 100% sure. I'm kind of in a stage now where I've got a few really, really good customers who are sending me very low volume or one-off parts, and they know what it costs to do those parts, and they're happy to do that. That's really good. I like doing that stuff. Keeps it fresh. 5 years' time, potentially finding a little bit of a niche would be good. Don't know if I've found that yet, but yeah, that'd be amazing. Be that in one type of car, or whether it's in one type of part for a car. So you'd be making the same part for different cars, say intake manifolds or whatever.
Okay. Now, another element, which is the reason you're joining me in person for this podcast, is you've recently relocated the business from Auckland, which is near the top of the North Island of New Zealand. And I know that most of our listeners probably have no idea of the geography of New Zealand, but you've moved to the South Island, and I'd argue the best part of the country and probably the best part of the world. You've moved to Cromwell. Give us some insight into what that move was all about.
Yeah, so I've got to a stage where I'm outgrowing the workshop that I have been in for the last few years. I knew that was going to happen at some point, but we came to terms with the fact that finding a workshop in Auckland is pretty hard, pretty expensive, and we really like the area down here. We've always loved it. It is, as you say, potentially the best part of the world.
I'm definitely biased, but if you like outdoor activities, this is absolutely the place. So yeah, I think you've made a smart move, I believe.
It's beautiful down here. So yeah, and New Zealand doesn't have a huge amount of racetracks, but it just happens to have one next to the new workshop, which is also a big draw card.
Yeah, I mean, that was one of the reasons we moved here. Getting access to a racetrack in New Zealand's difficult. We use the racetrack for filming a lot of our course material, and Highlands Motorsport Park, which is just down the road from us, 40 odd minutes away, runs kind of a bit like a golf club, really. So you buy a membership and you've got access to the track, and that's been an absolute game changer. It also doesn't hurt that it's arguably probably one of the best tracks in New Zealand. Really, really fun to drive on and technically quite challenging. Let's move on. We've talked about your background in machining and CNC, but as you get into CNC, 3D modeling and CAD software kind of goes hand in hand. Did you have any prior exposure to this sort of software and learning how to use it, or did this come later as well?
Yeah, so computer-aided design has been part of the job pretty much since when I started training in the Air Force, mainly through things like, you learn about engineering drawings. So you're faced with a drawing that's full of dimensions and tolerances and stuff like that. So you've got to learn how to produce those drawings, and you just naturally end up doing some modeling. We did a course in the Air Force with SolidWorks, and I still use SolidWorks to this day. It's great. It's amazing. There's a lot to learn, and I'm probably like a quarter of the way through it,
Yeah.
I feel.
This is definitely a very complex piece of software. I'm interested in terms of the different software packages, and there are a few. Of note, obviously, SolidWorks you've mentioned. There's also Fusion 360, which I think the enthusiast market has gravitated towards because essentially for home use, it's free for the most part. What's your sort of take on, I'm guessing you stayed with SolidWorks because it's what you knew, but in terms of the differences between, if we just look at those two, what would you say you think the advantage of SolidWorks is?
SolidWorks is, as I understand it at the moment, it's still a more traditional CAD program. Fusion has done really well because it's very intuitive in how it's operated, easy to pick up, whereas SolidWorks, even today, is it's a little bit more tuition needed to get into it. Fusion has been good for the industry. It's got a lot of people into CAD. By it's free, you can grab a membership for a student, sweet as. Yeah, I find SolidWorks, when you sort of get to the pointy end, it starts doing a few extra things that you might not be able to do on Fusion.
Yeah, okay, no, fair enough. What was the learning curve of the 3D modeling side of CAD like for you? How much of a challenge has that been? You sort of mentioned you're still kind of always learning, but I guess that's pretty natural.
There's so many different parts to using a program like SolidWorks. SolidWorks will do solid models, which is 99% of my work. It'll also do surfacing, which is a whole new ball game, which I've been doing a little bit of lately. And
can you explain to us what that is?
So solid modeling is basically extruding a part that's a solid, say a cylinder or a cube, whereas a surface model is literally just the surfaces. You're, from what I understand, and I'm getting there, you're drawing up surfaces in between profiles, extruding them the same way, but it's definitely a different way of going about doing things. You can do a lot more interesting shape with surfacing, but yeah, at the moment it's definitely not my forte.
Also worth mentioning here that while, yes, there's definitely differences in the way the likes of SolidWorks or Fusion 360 operate, the core principles, I think, of 3D modeling, those pretty much are the same across the two pieces of software. What I'm getting at here is if you've learned on SolidWorks, it would be a relatively straightforward transition to Fusion 360 and vice versa. Do you think that's fair to say?
Yeah, I think that's fair to say. I'm definitely getting to the stage where it's a little bit tricky if you've spent the last 15 years using SolidWorks and then try and jump into something like Fusion. It's definitely doable, but it takes a little bit of time.
Absolutely.
Yeah, they just work on slightly different principles to do the same thing. So you're doing it a different way. You end up with the same sort of thing at the end of the day, but it's just, learning where all the buttons are. And
in terms of your background in traditional machining, do you think that's offered you some advantages when you've jumped into SolidWorks in terms of designing parts that are not just effective and are going to do the job, but actually designing parts that are going to be easier and hence more cost effective to physically produce. And I'll sort of add a caveat here. I went through university and did a term where we had to do a paper on using SolidWorks. And back then, with absolutely no understanding of machining at all, literally had never seen a mill or a lathe. Like, great, let's have at it. I can make this part, and it's the most complex thing in the world. And
Sky's the limit, right?
It ticks all of the boxes, but also would have been completely impossible to actually manufacture.
Yeah, that's a big thing. The most common thing is that you can't machine a square corner with a mill. There's got to be a round part in there somewhere. And so when
you're talking an internal corner here.
Yeah, that's right.
Because the cutter is, no matter how small it is, has still got a circular profile.
Yeah, that's right.
So it's going to have a radius.
Yeah. And it's really great when some of my customers do their own designs or have their own designs done. And it's awesome when you get someone who understands the machining process and sends you a design where you're not trying to jam a 8mm cutter 150 mils down a square corner. Some things just don't work. Yeah, so it definitely helps you. If you know how the process works, it definitely helps you to draw it. And you can almost draw a part in the same way that you'll machine it.
Okay. The other element with the likes of SolidWorks and Fusion 360 is they do offer some more advanced processing capability. I'm talking here about the likes of finite element, stress analysis, CFD, generative design, etc. Are you using any of those more advanced features?
I don't tend to use them that often. I have used FEA a couple of times in the past. I have used it myself a couple of times, although recently I've got a good friend of mine works in an engineering company where they use it all the time. And so if I need any FEA work done, I'll farm out to him.
Probably actually worth just stopping there and breaking down that term as well, because again, we've sort of glossed over it pretty quickly. I'm guessing there's a few people who maybe aren't connecting the dots there. So what does FEA actually allow you to do?
So FEA, or finite element analysis, it's basically testing the part that you've drawn up. It's basically testing it in the environment that it'll be used in to basically make sure it's not going to break.
Fit for purpose, essentially. You can apply the stresses in the virtual world that the part is likely to experience, and the software is going to show you deflection or whether the part's just going to fail immediately. So you've got that confidence that you've built a part that's going to actually work in service.
Yeah, correct. It also goes to the next step where if you're trying to make a complex part for a racing application, obviously you don't want the heaviest part in there. So FEA can not only tell you whether that part's going to work or not, but it can show you areas where you can remove a little bit more material or a little bit more weight and things like that.
How does that sort of work in conjunction with the basics of engineering? So again, a lot of our listeners will probably be doing this at an enthusiast level and they haven't done a degree or a trade. They haven't got a sort of a technical understanding of engineering principles, which obviously will always guide you in designing a part the right way in the first place. So you've obviously got that background in engineering principles. How do the two correlate there? What's more important, your engineering understanding, sort of looking at a part and kind of just knowing from experience how much material, what type of material is going to be required for the required strength versus using FEA to tell you that information?
Yeah, there is a huge amount of that comes into it. So if you've got the engineering background and a little bit of experience in the parts that you're making, then you do definitely get to a stage where if it looks the part and you have a good feeling that it's going to be somewhere in the ballpark, then you're generally correct with that. FEA would come into it, but, and I'm going to use a term thrown around by you yourself, Andre, but it's a term called garbage in, garbage out.
Absolutely. And I was going to lead into that, but take us through it.
Yeah, so if you're designing a part and you want to perform an FEA study on it, if you're telling it porcupines or the wrong information, then it's just going to tell you the wrong information at the end of the day and you're not going to get anywhere.
And I mean, it's not even necessarily about telling it lies. I mean, sometimes we're trying to estimate forces that at the enthusiast level, we don't have the ability to accurately measure those forces. So there's a bit of guesswork involved. And if you guess wrong, no miracle here, the output's also going to be incorrect. So
That's right.
yeah, that's always been a bit of a challenge as I see it. Not that I've personally been involved in that side of things, but yeah, I mean, it is garbage in, garbage out. You've got to give it the correct information if you want accurate and realistic data out of it. It comes down to another term as well around the design of parts that are mission critical, which is a safety factor. And can you talk us through what that is and how you would incorporate safety factors?
Yeah, so that's a really good use of FEA, is you can, not only can you apply the forces that it's going to see, you can apply a multitude of extra forces to that part. You can apply forces that if that car's going to see that force, then there's way bigger things to worry about than your part breaking.
Yeah.
And that's great, because if you can put a part into service and know that it's never going to fail, assuming that all the material's correct and it's been installed correctly, then that's really, really good. But yeah, it does take that knowledge of how the software works, and then, yeah, as you say, those engineering principles that go along with it.
In terms of part failures, this sort of came to me while you were talking about that. Another element besides the actual design would be maybe imperfections in the material itself, which often could be outside of your control. How much of an issue is that? Does it come down to the specification of the material you're using, or the supplier? Are there better grades or better suppliers of the same grade of material? I'm interested to get your take on that.
Yeah, so it's a tricky situation, that. Yeah, I have had experiences with defects in material going way back to when I was doing non-Wankel rotary aircraft engines. We had a piece of 6-inch 4340 chromoly steel that we were using to machine the master rod of the engine, which is where all the connecting rods connected to. And we had that NDT'd, which is non-destructive testing at the time, and that was found to have cracks in it, which is really not great when the crankshaft is supporting the engine spinning around.
Yeah, that'd be the last thing you'd need.
Last thing you need. And it's a really tricky situation, because you can go back to your supplier and say, hey, look, this is, cactus.
So this is before the part's actually been put into service?
Yeah. You definitely, you're not doing NDT or that on all parts, but you'll do it on some really mission critical parts.
I can assume at the point that it went through this NDT testing that you've already invested a large number of hours in actually machining the part, just to throw it in the bin.
Yeah, a lot of time, a lot of machine hours, a lot of design time, a lot of setup time. It's unfortunate that you find that stuff right at the end of machining when it looks great and it's ready to be installed, and then you have to turn it into a really good looking paperweight.
Yeah, that's unfortunate. I just want to interrupt our interview with Dan for a moment and talk about a course that I know you're really going to like if you're enjoying this interview, and that is our 3D modeling and CAD course. This course teaches you all the skills that you're going to need to know in order to design components using CAD or 3D modeling software. In particular, you'll learn the basics of CAD and design fundamentals. This is an intro to engineering or mechanical engineering, so you've got an idea of the forces involved in a component, so you can design strong parts that are fit for purpose. You'll then learn the solid modeling basics as well as sheet metal modeling basics. You'll learn about assemblies, analysis of the parts you're designing, post-processing of your designs, and you'll learn some of the advanced CAD techniques such as finite element stress analysis. You'll learn about 3D scanning and 3D printing, and then we've put together a 5-step CAD design process, and this simplifies your design process when you're using CAD software. At the end of this, you will also get a certificate of completion, and all of our courses include a library of worked examples where you can watch, in this case, that 5-step CAD design process being put through its paces, designing a real part for a real race car. This course is usually $199. You can use the coupon code Kiwi CNC 50. That'll get you 50% off that particular course. Even if you use that coupon code, you are still protected with our 60-day, no questions asked money-back guarantee. Zero risk giving it a test drive. We'll put a link to that course and the coupon code in the show notes. Let's get back to our interview with Dan now. All right, now just coming back one step, we talked about generative design, and you mentioned you haven't used that, but obviously you're aware of it. And for those who haven't heard that term, basically we're seeing a lot of parts pop up on Instagram feed of these beautiful organic looking shapes. And the generative design, basically you can input your requirements in terms of strength or weight or mass of material or volume of material, whatever it might be, and basically using AI, the software will pop out a part that meets your criteria. I'm wondering what your take on this is. Generative design kind of the next big thing, or is it a bit of smoke and mirrors? One of the concerns I sort of see, again, coming at it from a non-machinist background, but some of these parts look like they'd be essentially impossible to machine using traditional techniques.
Yeah, it's a really interesting technology. I hope that it's good. I think it looks amazing, some of the stuff that pops out. There's always going to be a case where you start with a 3D printed part like that, and there's going to be some machining operations at the end of the day. I hope that it goes forward and works out, but at the moment I'm sort of yet to see anything kind of come to fruition. And like you said, I haven't really had a hell of a lot to do with generative design.
Yep, no, fair enough. All right, let's dive into the process you've been going through when it comes to manufacturing or designing and manufacturing a part. The first part of this is, you've already mentioned some of the parts you're making are kind of driven by customer demand, basically. Here's a thing I want you to make. But beyond that, how are you deciding what parts to make if you're designing something in-house?
So generally, a customer will approach me with something that they want to make. They say, hey, Dan, can we make such and such? And you go, that sounds like a cool idea. Yeah, sure. Generally, you'll be replacing a factory part on a car, let's say. So the first thing would be to say, can you send that part through to me? We'll get the part, measure up all the critical dimensions and start drawing it up. And then you'll be asking the customer what you'd like changed with it. If you want more volume in a certain area or something like that. The other thing is a lot of the time you're working with constraints within the car. It's got to fit in the car at the end of the day. And you're going from there and you're kind of locking in all of the non-movable parts, starting to draw that up. And then you kind of just flesh out the middle in SolidWorks and then go back and forth between yourself and the customer a couple of times with pictures, a couple of designs, cross-sections, a few questions whether you might have issues with getting access to some parts or how you can actually machine it. If it's been a factory cast part that you can't get CNC mill to drive all the way around the corner and machine the back of something, and you have to turn it into maybe 2 or 3 parts to make the full assembly.
Yep.
And that comes with a few challenges. Once you're happy with all of that, the customer signs it off, says, that's great, and then it's into machining and tear into it.
Coming back one step in terms of the measurement process, because obviously that's one of the elements we absolutely need to get the dimensions correct so that it's physically going to fit and bolt in to the places it's supposed to. I'm interested, are you doing these critical measurements? Are you taking these manually or are you using techniques like 3D scanning?
Yeah, a little bit of a combo of everything. So there might be a part like a sump, like RB26 sump. You'll get the sump in your hands. You can physically look at it, measure out some parts on it manually. You can then, a lot of the time with something like that, you can bolt it into the CNC machine and then use the CNC machine as a measuring device. So
okay.
So yeah, you can,
because that's plotting the XYZ positions.
Yeah, you can find thread positions and offsets of things in the machine. You can do it that way. And I'll use a 3D scanner in cases of where there's some interesting contours that you need to get in there that are tricky to measure by hand. Yeah, so you use a combo of all three. There's one time where the 3D scanner comes in handy is things like with motorsport uprights, you'll find that a lot of the bush bores are all off at crazy angles. Very, very hard to measure that.
Yeah, sure. Yeah, that makes sense.
Yeah, so scanning is a really good way of getting those center lines and offsets and stuff.
Obviously, with the 3D scanning, there's a variety of technologies, products, and price points that go along with this, right down to the point, we teach in our 3D modeling and CAD course that you can use any current cell phone that does face recognition. It's basically LiDAR, so you can use that. And I mean, obviously the accuracy is somewhat limited compared to a $100,000 3D scanner, but there's price points in between as well. Can you let us know what equipment you're relying on, kind of what the price point of that is, and maybe what the accuracy of measurement is?
Yeah, so the money that you pay for a 3D scanner is definitely, it's for the accuracy. So the scanner that I operate it's a PL2 scanner, and that's, I think at the time it ran about 10 grand US, and that will do down to somewhere between 0.5 millimeter, 0.2 of a millimeter accuracy, depending on how you've set it up, how well you use the machine, because it's not just pointed at something and then it goes into the computer and you send that on to the mill.
There's certain complexities. We've got a PL 3D scanner in-house as well, and our crew have been just about wearing that thing out. It's been amazing. I thought when we purchased it, like, yes, this is going to be a great tool, but probably of limited use. But I mean, just about every day of the week, they're scanning something, and seeing the flexibility of what they're able to do as a result. Key element with this is that we've been going through, and I want to get too sidetracked, a fairly significant rebuild on our Honda CRX. So the whole front end of that car was scanned, particularly around, we'd ordered a Hollinger SF 6-speed sequential gearbox for it, but Hollinger's lead times are huge, and we knew that going into it. So they actually supplied us a 3D model file of that gearbox. So my guys were basically able to build the front end of the car in Fusion 360 and basically know that everything was going to fit, right down to even designing and building engine and gearbox mounts before we get the gearbox. So really, really cool technology having that. But coming back to what I was going to say, there's a few complexities around scanning different materials. And again, I don't do this myself, but I see it being done. They don't really like shiny surfaces, do they?
They get very confused. Yeah, you try scanning a aluminium engine block with a bunch of machine faces on it.
Not too happy
and
about
it's
it.
got no idea what it's up to. Yeah, so you're using a combination of scanning targets, which are like little reflective spots, and that's your base map of how the scanner works out where it is in the world.
Those little targets are actually, I hate those things, because I come back to any of our cars and the job's been done, and I'm looking around, I'm like, why are there 100 of these little target dots stuck to the underside of the car still?
Yep.
Finish the job, peel them off when you're done. Yeah. The other element as well is sort of almost like spray paint, essentially, that, I guess for want of a better term, dulls the surface down, removes that reflectivity, allows it to be scanned, but is also designed to be easy to then wash off.
Yeah. So I use it's sublimating spray. So it sprays on effectively as a powder, and then it evaporates directly from there, and you get various different types and how long they last on the part. You do have to be a little bit careful with the use of them. For one, they're pretty expensive, so you kind of go a little bit sparing, but you get a little bit of a feel for what the scanner likes in terms of, ratios of how much of that spray you cane around the place, and the little dots that don't like to stick to oily surfaces. But it's an amazing thing. And like you say, I mean, engine swaps, it's great. You just scan the car, you set it up. I've recently done a new version of our RB26 sump, and part of that was ensuring it was going to fit into each GDR, being as there are a few little differences in between them.
Sure, but that sump will basically be the same, so it's going to fit the 32, 33 and 34 GTR.
Yeah, and I went around, scanned the bottom side of a 32 and the bottom side of a 33, bottom side of a 34, and then in SolidWorks you can overlay each scan and virtually fit your part to each of those cars. Things like that are amazing. You can scan a part, come home, forget that you didn't pick up a dimension off something with your ruler, and you've got it on your computer there to look at.
Yeah, definitely it's changed the game in terms of what is achievable. Once you've actually designed the part and it's got sign-off, actually coming back one step from that even, when you're doing a part, like let's talk about this GTR sump, I'm not actually sure if that was driven by a customer or you decided that this was going to be a Kiwi CNC product. But regardless, when you're dealing with a customer and they've got an idea and you sort of see the potential, like doing this as a one-off is going to be a huge amount of time. Hence, it's going to be a huge amount of expense for this one customer. I think there's a market for this product. We can probably sell 10 of them or 50 of them or whatever that may be. How does that negotiation go? Do you sort of work out so that you hold on to the IP and maybe the customer doesn't end up paying for the design work?
Yeah, that's a tricky one, and that comes down to a little bit of a weakness that I have in that I like a bit of a challenge. So that sump, the first sump that I did might have been 2019, I'm not too sure. That was a customer of mine out in West Auckland. You want to do one of these? And I looked at it and thought, that is like, nobody's going to pay that much for a billet dry sump with a diff stuck to the side of it, but it looks awesome. So I did the first one. I got 3 pieces of material. The main sump comes out of a 90 kilo piece of 6061. And I thought, I'll have 3 pieces of material, 1 for the sump, 1 for a screw up, it happens. The third one for maybe if someone in the future decided to have one. But in that case, if it's a job like that, I tend to keep the design, don't charge for the design work just because it's an interesting job. And that's potentially not a very good business model.
Well, definitely not for a one-off.
No. I think I'm lucky that I've sold a bunch more of those. Yeah, it turned out that people will pay that much for
that GTR market we've seen kind of explode, and particularly in Australia where you've got a handful of workshops each trying to one up the other. And I mean, now with these cars being worth sort of, you buy a stock R32 here in New Zealand, you're probably between 80 and 120,000 New Zealand dollars. So I don't know, what's that? Probably 70 to 90,000 US dollars. I don't know. I don't do the math on the fly, but a lot. So there's also a proven sort of resale, the cars that have been well modified with huge amounts of money spent on them, people are also paying what they're worth. $300 plus $400,000 is not absurd. So I think there is a market for those higher price point pieces. Could we actually put some numbers around this? So you mentioned you're starting with a 90 kilogram piece of billet. What's the sort of the price point that you're paying for that piece of billet?
Yeah, so for starters, the 90 kilo piece is just the sump itself. There's actually, in terms of all the parts that go into that assembly, I think it's 147 odd kilos all up. Whew.
Yeah, okay.
And at the end of the day, that all ends up being approximately 13 kilos. So over 90%, as I said before,
going in the bin.
Ends up in the bin, but that's cool. Yeah, so the price of aluminium has gone up since a certain person invaded a certain other person's country. It turns out that that certain person was quite good at making aluminium, and so the price of aluminium has skyrocketed, and it's not really a consistent price now. I know when I started out, I was paying anywhere around the $12 New Zealand per kilo range. Now I think that's like this huge bargain. It can be anywhere between, 18, 25, $28 a kilo.
And it's a constantly moving target.
Yeah, constantly moving target. And with things like those sumps, I've tried keeping the price down in between them due to, each time you do a run of things like that, you get a little bit quicker at it. You know what's going on. You can set the first one up, you can almost just run it straight away. So you are cutting down on prices each time, and it's a real kick in the nuts when the old aluminium prices going up at the same rate. But it is what it is. It's just sort of part of paying, Now,
I'm going to urge the people listening to hunt out Kiwi CNC's Instagram account. We'll definitely put a link in the show notes as well. And because obviously you need to be able to visualize these things. It is an absolute work of art. In terms of the finished price to the customer, I'm guessing this is, again, a bit of a moving target because of the aluminium price that you mentioned, but can you give us sort of a ballpark of what that actually comes out to as a production item?
Yeah, so our retail price on that sump is 9,500 New Zealand dollars plus tax wherever you are, and obviously shipping, and that's coming down slowly.
I mean, not cheap, but again, you've got to appreciate how much goes into this and what you're starting with versus what you end up with. So, I mean, it's definitely not going to be a product for everyone, but good to get some insight into that. Now, in terms of once you've actually got that product designed, is it straight into machining from a piece of billet? Is there any 3D printing done to validate the design before you actually get into a very expensive chunk of billet? Do you sort of have to do any tests or test fits checks or anything like that?
Yeah, so I bought a 3D printer at the time because of that, and checked out a few clearances, and that paid it for itself straight away because I found that it didn't clear.
Much cheaper to find that out with
so
a 3D
great
printed part.
Print that out of about $3 worth of plastic and go and check it out. So that was really good. Having a printer, I've used the printer heaps. I'm using it right now, actually. I've got some parts that I'm doing that I've got to take back up to Auckland to test out, and it's amazing compared with setting the machines up, going through the whole rigmarole of making the parts and then finding out they don't fit. There's curveballs in there where, you can only design a part to that certain customer's specifications, and if you sell that part that you've designed to someone else and they're using it differently, then you're obviously not. You start running into issues like we've had. Aluminium rods is a thing with that sump. Aluminium rods.
Oh, clearance for the rods because they're so much
A lot
chunkier.
bigger.
Yeah, that makes sense.
Yep, so things like that. We changed the diff because, people like to run R34 ratios in them, which are 3.54s. They've got a much bigger pinion wheel, so that was that's another change to the design as through. Yeah, so I think things like that sump's on its 4th revision. Each time, you try and get a little bit more weight out of it and try and add a few things to help people out.
One of the elements, and again, just sort of scrolling through your Instagram feed, I mean, you can make a part that is going to be fit for purpose and do a great job, but look pretty, how would you put it, shit.
Yeah.
Or you can make a part that's going to be just as effective in terms of its function, but it looks amazing, it's a work of art. How much sort of emphasis do you put on the form element, the physical look of the finished part?
Yeah, that's very tricky, and I like to think I do put quite a bit of effort into trying to make it look nice, because it may as well look nice. You're spending a lot of money on a part, and I love my job making cool parts for cars. That's it at the end of the day, and if they don't look mean when they go out, there's nothing better than a customer going, holy shit, man, this looks cool.
Absolutely.
That's so good.
I think in this day and age as well, with so many competing companies, if you weren't making aesthetically pleasing parts, you're probably going to be dead in the water as well.
Yeah, correct. Yeah, I think you got to keep up. And I mean, I'm not aiming to take over the world or anything, but I like my little corner of doing those sort of parts for people.
Now, in terms of 3D printing, that's a technology that we've seen develop significantly over not even that long, actually, and it seems like it's sort of the price point for 3D printers is really sort of plummeted. We bought a 3D printer back in 2020 when we went into lockdown, and I think that was maybe about $700 we spent on it, and it's been such an amazing investment. What should someone who's listening be looking for if they're in the market for a 3D printer? Have you got any sort of buying tips, brands, etc., size? Is that a consideration? Yeah,
you definitely pay more for more size. There's kind of a standard size 3D printer that you're looking at to start with, which is, I think mine does, it's only 250 by 210 by 250 maybe. It's like a Prusa Mark III at the time, and I think, like you say, mine was about $750 US.
Yeah.
I think. Really well known brand. It turned up, and they say it's a kit set, and you go, oh yeah, sweet, it'll take me a couple of hours to. That's like a whole day job, man, to put that thing together.
So it's the flat pack 3D
printer.
Yeah,
flat pack has. Yeah, it's got like this novel that turns up with the instructions of how to put it together. But in saying that, it started up, and I've not touched a thing on that printer for 4 years, and it just goes, it's great. You can get printers off places like, AliExpress. You've just got to put in a little bit of extra work from what I've heard, a little bit of tweaking to make them go right. But if you're
that way inclined, you can save yourself a bit of money.
Yeah, totally. And also you can get a fairly big printer for the same price.
Yeah, one of our past guests, Mike from Stanceworks, I remember watching one of his videos, and he'd bought maybe the same sort of AliExpress printer, wasted a bunch of hours trying to get it set up, basically abandoned the project and ended up buying a second one that was kind of good to go out of the box. So, and there's definitely an element of that to consider, but like most things, you get what you pay for. Another element with these in terms of the size as well, obviously bigger is better, and it always going to come down to the size of the parts that you actually want to print. But even with those smaller printers, you can actually break the part up and print them in sections and then kind of assemble them together, can't you?
Yeah, you can. The other thing you can do is you can do some tricky stuff, like just for the print, you can design little interlocks in them so that they literally click together like a jigsaw when you're finished. Or, you're just printing for parts like mine, you're just printing cross sections, and they don't have to be that thick. So you might even only be printing out a corner where it might be, you're just looking to validate the clearance around something in particular. So printing out the whole part is, not only does it take, they take a long time, but it's not really necessary for a lot of it.
Yeah, we just went through this. Connor, who's our in-house CAD guy, he developed a billet rocker cover for our SR20, and it wasn't just for the bling factor. There were some actual reasons behind why we needed to go down that path, but obviously it's going to be a pretty expensive finished product. Again, you're starting with an expensive piece of billet, so he went and printed a few cross sections with our 3D printer and tested the clearance to elements like the cams and the cam gears and the chain, etc., so that he had the confidence that when we finally got the part made, it was actually going to fit, which is always confidence inspiring.
Yeah.
Let's talk about another element with the machining process, which is actually taking your 3D model and converting it into toolpaths that you can feed into the CNC machine. So again, most people kind of think that once you finish your model in SolidWorks, you just press send and it goes to the CNC machine.
Button.
Yeah, and out pops your new billet sump for your GTR, but it's not quite that straightforward. So can you talk to us about how that works?
Yeah, so when I referred to the machine as computer numerically controlled, it's not looking at the model and telling you, oh, I'm just going to roll around this corner and, tickle it up. It's literally reading G-code, which is basically a massive long list of coordinates and speeds and feeds and stuff like that. And to do that, you've got to create the toolpaths to begin with. So you take the model that you've made, and then you've got it in your software, and you're manually, most of the time, adding in which operations you'd like to do, which cutter you want to use for that, what sort of step over you're running, how fast, you've got to know what you want the CNC to do. The big thing at the end of the day is that the CNC isn't smart. It will do exactly what you tell it to do. And if that means it's going to plunge into your work at max chat and smash off a, $800 cutter, then it'll do that, no problems.
It must be very satisfying to watch.
Bro, I can't watch those, the CNC crash videos.
Yeah.
Can't do it. I can't do it. It's so bad. It's you can see what's happening straight away. Real bad. So you are programming each operation in your machining software, and then once you're happy with that, it's got a validation tool where you can watch it in a simulation being machined. It'll show you if you've set up all your tools in the software correctly. It'll show you if it's doing anything wrong.
Mm-hmm.
It doesn't tell you things like how much load there is on the machine or anything like that. You've got to know.
So this isn't something that a home enthusiast is going to be able to jump into and do. This requires some extensive background knowledge.
Yeah. And this is where your trade training and manual machining comes into play, because you know how much a cutter will take, how fast to run things.
Having said that, for the enthusiasts out there at home who are using SolidWorks or Fusion 360 and modeling their own parts, obviously, most enthusiasts aren't going to be in the market for their own CNC machining equipment, but can someone send the likes of you a model, and then you go through the computer-aided machining process to actually set that up for your machine and make the part for them?
Yeah, 100%. And it's a case of talking to the customer, potentially sending the model back with a few, vivid lines on things, saying potentially change it here, or alter this radius a little bit to make it easier to machine, or something like that. I'm more than happy to go with that, go through that with the customer. It's good. It's education. It's fun. And then, you you're basically taking their model and then doing what you need to do to it to get it through. The thing that I have found pop up if people are interested in CNC machining is the invention of desktop routers. They are awesome. And if someone's got, a few $1,000s to spend, then you can buy something like that and make, some of your own parts pretty easily, and it's virtually the same thing as the mill, just on a smaller scale.
Yeah, we've got a simple router in the workshop as well, and the guys will machine something out of a piece of MDF. It's low cost, low risk, and for prototyping and test fitting, yeah, absolutely perfect before you actually get something machined out of a much more expensive piece of material.
Yeah. I mean, probably not going to put one on your desktop in your house, but yeah, they're great to play around with.
If someone listening is interested in learning the skills of 3D modeling or machining, you've got any tips on sort of that process? I mean, obviously it's a bit difficult because, as we've already discussed, there is a specific trade qualification process you can go through, but what would you recommend?
If you want to get into it, it's easy enough with the likes of Fusion to get a seat at Fusion for cheap, being a student. That's fine. There's no end of YouTube videos on how to use.
Definitely.
Yeah. And so you can, if you want, you can learn at home. The best thing I've found through learning how to use SolidWorks is to do your own stuff. So you look at a project you've got for your own car, or, just look around you and just try to draw what you can see. You got your computer monitor in front of you, try and draw that. That's really good. Instead of going through the tutorials, I found that the tutorials, because you don't really have any connection to the parts.
Definitely makes it a little bit hard to really sort of get your head around the usefulness, right?
Yeah.
As opposed to making something that you can understand and see a useful purpose for.
Yeah, that's right. Yeah, and you do quickly pick up the basics from there, and it's just a case of experience, really.
I just want to interrupt our interview with Dan for a moment and talk about a course that I know you're really going to like if you're enjoying this interview, and that is our 3D modeling and CAD course. This course teaches you all the skills that you're going to need to know in order to design components using CAD or 3D modeling software. In particular, you'll learn the basics of CAD and design fundamentals. This is an intro to engineering or mechanical engineering, so you've got an idea of the forces involved in a component, so you can design strong parts that are fit for purpose. You'll then learn the solid modeling basics as well as sheet metal modeling basics. You'll learn about assemblies, analysis of the parts you're designing, post-processing of your designs, and you'll learn some of the advanced CAD techniques such as finite element stress analysis. You'll learn about 3D scanning and 3D printing, and then we've put together a 5-step CAD design process, and this simplifies your design process when you're using CAD software. At the end of this, you will also get a certificate of completion, and all of our courses include a library of worked examples where you can watch, in this case, that 5-step CAD design process being put through its paces, designing a real part for a real race car. This course is usually $199. You can use the coupon code Kiwi CNC 50. That'll get you 50% off that particular course. Even if you use that coupon code, you are still protected with our 60-day, no questions asked money-back guarantee. Zero risk giving it a test drive. We'll put a link to that course and the coupon code in the show notes. Let's get back to our interview with Dan now. Now, I need to go completely off track here, but this has been a burning question since the start of this interview, and maybe we can put a link to this article actually in the show notes as well. But you build a van, maybe a van boat. I'm not quite sure how you describe this, and you drove this or sailed it. Again, I'm not quite sure what the right terminology is here, across the Cook Strait. Now, obviously, most people don't know what the Cook Strait is, but that's a large body of water between the North Island and the South Island of New Zealand, and normally we catch a ferry across that body of water, which takes a few hours. I mean, I don't even know where to start with this, but what on earth brought that about as a good idea?
It was a while ago. Me and a course mate of mine were on our training senior course down in Blenheim, and they've got what is called an engineering club. So, you pay a membership to have access to a yard full of tools, hoist,
Right.
welders, stuff like that. So we used to sort of frequent that place and muck around on things quite a bit. And then Top Gear did a amphibious
I vaguely remember that. It was
episode.
across the English Channel or something, I think, wasn't it?
Yeah, so they never, I think Clarkson got towed out at the end of that. But they did it twice, and the episode before that was hilarious. They were in a lake, they're just being useless, great times back when Top Gear was, classic. So there was that popped up, and there were quite a few beers involved, and we decided to go to Motueka just up the road and came back with a 4-wheel drive Town Ace that had a crack right through one of the pistons.
Right.
Didn't run so good, and just set about trying to make the thing float and drive. And Adam, this other guy, is as stubborn as me when it comes to people telling you that you can't do something or that it's not going to work. We had, people betting us that it wouldn't work. We got a keg, bet that it wouldn't work. It worked. Didn't go very fast in the water. We sealed the engine and gearbox inside the van and sealed the inner skin of the van, filled every available space inside the doors and cavities in the van with TV boxes and miscellaneous polystyrene.
Right.
And then we locked the rear suspension down, removed the springs, welded in bars to stop it going anywhere, and then routed the rear drive shaft to a propeller, which turned out it was pretty tricky at the time because it's a left-hand propeller, which turns out isn't very common with displacement hulls, especially with our budget. And then so we had vacuum operated selectable front wheel drive and 5 gears in reverse for the propeller. So we ended up taking it up the road to Picton and driving it around in the harbour there, and drove it out into the Marlborough Sounds, and had a few real good times on it. And then we hadn't even decided that it was a good idea to go across the Cook Strait until we sort of worked out that it wasn't going to sink.
Yeah, it's probably good to know. I'd still say that good idea is probably questionable, but let's roll with it.
Yeah. So it went pretty well. We decided that we were going to drive across Cook Strait, but we ran out of time on our course, left the van down there, went to our various postings around the country, and then one of the news stations here, it was Campbell Live, if you remember them, flew us down to the day before Father's Day to do an article because people had seen this thing cruising around in the harbour, a couple of idiots hanging out in it. And they sent us down, got a camera crew, we drove them around inside the harbour, and then we got a text from one of my old bosses that I worked at. I got the propeller off him, used to work at a boatyard. He said, "Hey, Cook Strait looks mean tomorrow." So we said to the crew, "Oh, we might drive to Wellington tomorrow." And they were like, "Holy shit. Okay, how do we do that?" And so we had a support boat, which in the end we didn't actually need, which is good.
Yeah, always best.
They ticked along with us. It was funny, there was a guy from the Transpower who they run the undersea power cables in between the North and South Island of New Zealand. He called us up, took us to a bar in Blenheim, and he turned up with a suit and a suitcase and all that stuff. And he tried telling us not to do it because if we sank and damaged the power lines under the water, it was going to be, several $100,000 worth of... We're like, we don't even know if it's going to sink. It's so full of polystyrene. So we did it anyway, and it ended up being their helicopter that they used to get a whole bunch of the shots that you sort of see.
Right.
It took ages. We took a few beers and a few things and had an inverter with a house stereo in there that we're listening to Metallica and Pantera all the way across, and it just sort of worked, which was it was
Well, I mean,
amazing.
it's a novel application of some out of the box engineering thinking, and I mean, I see that news article was going to go one of two ways: either a success or idiots rescued by Coast Guard. But
Yeah,
fortunately, it went the right way. So,
yeah,
yeah, I
yeah.
mean, I guess it's always an interesting story that you'll never forget. All right, let's move on and we'll get this thing wrapped up, Dan. We've got the same three questions that we ask all of our guests, and the first of those is, what's next in the future for you? And I mean, I'm guessing you've only just moved to Cromwell, so yeah, what's it look like, do you reckon?
Yeah, pretty good. Apart from the fact that I've got this Friday, I've got to jump back in the truck and drive all the way back to Auckland for another load of stuff, which is 1,400 k's away.
Plus that cook straight.
Yeah, and the Cook Strait. I'm taking the ferry this time.
That's probably smart.
Yeah, so my machines are being brought down in a few weeks' time, and hoping to get up and running within the next month, which will be great. In terms of what's going on from here, I'd like to work on a few other things in my business apart from just cranking out the parts. A little bit of professionalism wouldn't go astray. Things like a little bit of merch and that sort of thing. Maybe the odd video and all that. Getting my own proper workshop set up and moving forward with that. Potentially maybe a development car or something like that would be cool. But yeah, definitely going to just play it by ear in the new place until we're settled in.
Fair enough, makes sense. Next question, is there any advice you give to a younger version of yourself to help reach where you are today in your career faster?
Yeah, I think most of that would be business advice.
Sure.
If you're thinking about starting your own business, would be a really good idea to get advice, get info, advice, whatever you can. Do a business study degree, whatever, to get that extra, not only the skills but the attitude involved. It's not a hell of a lot of extra work. It's just a different outlook on the job, and that's been a huge learning curve for me. It still is.
And I've talked about this numerous times on the podcast in the past, but it's that sort of classic entrepreneurial element of, person is good at something, makes a business out of doing that something, and realizes all of the other things because you don't know what you don't know.
Yeah.
Stepping into business. I don't know if I'd say a business degree is necessarily an essential, but I mean, there are a variety of different ways you can go about that. I mean, personally, I kind of jumped in because I was good at tuning cars and built a business around that. But I was fortunate enough to end up bringing on people with the other skills to run the business side of things. My business partner to this day in High Performance Academy, Ben, his background or his specialty is the online marketing and business systems, and our skills complement each other really well. Another element I'll add into this as well, back with my old business, Speedtech Motorsport, when we sort of took that from what was at the time kind of a hobby business that was paying for my drag car addiction and decided, hey, look, we're going to actually make a go of this. We actually ended up using a local business coach, and that was a real game changer for us. And just having that coach, you're accountable to someone. We're meeting once every couple of weeks, and all right, well, did you do those things that you said you were going to do? No? Well, why not? Whereas if you're not accountable to anyone, it's easy to just sort of let things slide and no progress gets made. But the other element is, I think, almost irrespective of the business you're in, the small business operator, it's always the same repeated problems that crop up across every industry. So, using a business coach, they know these problems and they can get you on track and get you to focus on those problems. Sometimes just having a sounding board is really important. And just, again, every couple of weeks, a meeting to keep you on that track and accountable.
Yeah, I definitely have benefited from a mutual friend of ours has been really, really great in terms of, getting the attitude right from the start. He's real sharp on that stuff. And that's been really good without having someone around to, ask all the dumb questions, and without having someone with a different attitude to question why you're doing something or why you're not doing something. Then yeah, it's really, really handy.
Absolutely. Right, last question for today, Dan. If people want to follow you and see what you're up to, how are they best to do so? What are your social media accounts?
Yeah, so you can find me Kiwi CNC on Instagram or Facebook. I do have a website that I need to do a little bit more work on, kiwicnc.com, or just find my phone number on one of those websites and give us a ring and have a yarn.
Perfect. And as usual, we'll chuck those social media accounts into the show notes to make it super easy for people to find. Oh, look, Dan, it's been a pleasure having you on the podcast. Great to have an in-person podcast for a change as well. And
Thanks, man.
I can only imagine that having you 40 minutes down the road from us might be beneficial to us in the future when we want some parts machines. So can't wait to work more closely with you.
I'll let you know when I'm up and running.
Perfect. If you enjoyed this episode of Tune In with Dan, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Jourdain from the UK, who has said, Andre and the team at HP Academy have created an amazing method to get bite-sized information from the performance world. The podcasts are great to listen to on my commute to work, and I no longer feel like my commute is wasted time. Well, glad to hear that you've found a better way to spend that commute, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.